Hello everyone, Namaskar, Sawadee. Welcome you all to the Rubber Industry NewsHour, a weekly program for the rubber industry organized by Technobase. As you know, as I mentioned to you, this is organized by Technobase, and you can always find more information about Technobase at technobase.org. I'd like to give you a quick introduction to the Technobase. Please allow me to introduce to you all what kind of services we offer for the rubber and tire industries. It is actually based in Thailand. Technobase is based in Thailand, established in 2005, and it is recognized as the International Resource Center for Industries and Technologies. Our main business, the foundation is based on the professional education. Along with that professional education, we offer a number of business services for the benefit of the professionals as well as the businesses. We have various business services. We organize exhibitions, we have training programs, conferences, we have networks, we have talent search, knowledge test, consulting program, and also we offer a marketing and branding program. So it's a combination of professional education and business services. When it comes to the industry side, we have two segments: polymer and non-polymer. When it comes to the polymer, we focus on the rubber, plastics, polyurethane, and also coatings and adhesives. And non-polymer size, chemical engineering, energy environment, water and membrane technology, filtration, separation. These are areas we cover the same, but rubber is one of the main segments of the Technobase in terms of business services we offer. Our services are pretty much global. And let me give you what we've planning in 2022. We have two exhibitions organized by the Technobase, GRT, which is our regional expo in Southeast Asia. We are going to organize next year on 29th to 31st March. And we do have another expo, Arab Rubber Expo, which will be held on the 21st to 22nd November in Sharjah. It's near Dubai, United Arab Emirates. We offer lots of online training program. We have a rubber industry online training program. Probably we are the specialized organization which offer the huge list of the training programs for the rubber industry. Through our platform called NewsHour Webinars. It's an online platform for the professional education. And we have various well-experienced and knowledgeable experts from across the world offering this programs for us, and they come from different parts of the world. We have short training programs, we have master classes, we also offering a diploma program next year. You can always check our website knowhow-webinars.com, and we introduce to you next year we do this rubber industry technology and management. This is purely focused on the non-tire rubber industry. Okay, and we have 3-month diploma program which is going to start next year in June, 3-month program. Other than that, we also offer help the companies who are interested to develop their manpower, guiding them what kind of training program suitable, how to improve their skills, and also brainstorming sessions as well. And we have a number of books we publish by Technobase. You can always check our website store.technobase.org. We publish very specialized books which are not available in the market, and so these books are available through our Technobase store. And we have a bi-monthly magazine. It's a joint publication by the Rubber World. Technobase and Rubber World jointly published this magazine. Now it is available in only digital format. You can always subscribe at rubbertiredigest.com. It is free to subscribe. Currently there are 6,000 plus readers there. This is a NewsHour program we started this year, every week on Monday. And we have this Rubber Industry Connect program to help the companies to promote and branding them. So through our Technobase social media platforms. And we offer also service on the customer marketing, customer promotion, branding, social media marketing service also. We have their various networks. So on the Facebook, we operate Rubber Technologies Global Network. On the LinkedIn, Rubber Industry Network. On WhatsApp also, we have Rubber Industry Network. So there are these through the networks, all the members of the rubber fraternity, we connect and communicate and update them various issues. And also we use a video platform on YouTube, the Technobi channel, and on the rubber industry news hour. Most of the episodes we post them on the next day. You can view them whenever you want. I think most of our subscribers of this program, they watch on YouTube as well, on Technobi's channel. And you can always find me if you have any questions or any concerns about the Technobi's activities. You can write to me as well. Okay? So that's about the what Technobiz is doing. And again, I repeat that the rubber industry online training program, which we are developing extensively and with various experts. Please check our website, knowhow-webinars.com. You have updated information, and actually you can also download the file of the handout in the handout section of the panel. Okay, let's get to today's episode. We are on episode number 27. And today is 18th July for the Rubber Industry News Hour. Welcome you all. And today is only one topic, one focus. This focus on the graphene and the rubber industry. This rubber industry is Rubber Industry Talk. We have a next speaker, Mr. Peter Osborne. He is from the commercial manager of the first graphene. And after his presentation is over, we have various experts from the rubber industry joining as a panelist to discuss about the various issues about the graphene. So we have Dr. Brendan Rogers, Mr. Alan Whitley, and E. Paulinathan. So this is a main component of today's episode. Let me, before I go to that session, let me introduce some of the upcoming events which you may like to know, rubber industry upcoming events. The first I'd like to introduce to you about the rubber and tire industry, rubber and tire Vietnam, which will be happening on the 3rd to 5th August in Ho Chi Minh City in Vietnam. Let's have a quick look about the Vietnam Rubber Expo. The presentation is there. Tire Vietnam 2022, which will be happening on the 3rd to 5th August. I welcome you all to participate in this event. There is another event in Malaysia, IRICE, International Rubber Industry Convention Expo, which will be held on the 6th to 8th September at KLCC Convention Center in Kuala Lumpur, Malaysia. You can check more details about IRIC, irc.com.my. So I welcome you all to this event in Malaysia. There is another event that is parallelly which is happening along with the IRIC is RubberCon, which will be focusing on the new developments in natural rubber during the same period 6 to 8. This is organized by the Plastics and Rubber Institute Malaysia. So I welcome you all to participate in this RubberCon as well in September in Malaysia. I'd like to introduce to you the next event is IRC 2022 which will be in India during the 24th to 26th November in Bangalore. This is organized by the Indian Rubber Institute. Let me show you a short presentation about their technical program, which you may find interesting to learn about what kind of topics being going to be presented at the IRC 2022. And that's the technical program of the IRC 2022 in Bangalore, India. Invite you all to participate. If you would like to register, you go to the irc2022.com. Again, I repeat our TechnoBiz exhibitions. We have GRTE next year in Bangkok and also Arab Rubber Expo next year in November in Sharjah. So I invite you all to participate in this event as well. Rubber Industry Tech Talk. In this session, we are focusing on the graphene and the rubber industry. This program has two sections. First, we have a presentation, and then we'll have a discussions. You, all the audience, are welcome to post any questions you have. We can discuss in our discussion session as well. I'm pleased to introduce, welcome Mr. Peter Osborne. He's a commercial manager of the First Graphene UK Limited, to make a presentation on the graphene and the rubber industry. We'll learn about all about the graphene, what are the possibilities in the rubber industry, So let's welcome Peter to make a presentation now.
Good evening, Sharam. Param, can you see my screen okay?
Good, go ahead.
Okay, excellent. Well, we really appreciate your time and your audience's time to listen to a short presentation about graphene in the rubber industry. My name is Peter Osborne. I'm Commercial Development Manager for First Graphene. I've been in the graphene world for just over 7 months, and been in the polymer industry for the past 30 years. And the process that I'm going to take you through is just a bit of an understanding of where we are as a business, who we are, what we do, and then talk a little bit more about the different elements of graphene in the rubber industry. First of all, just a bit of clarification about graphene. So graphene itself, in terms of a material, we classify it as a next generation refined carbon. And the reason we do that is because it's effectively, when you look at the multi-layer graphene oxide, monolayer applications of graphene since it was discovered in Manchester in 2004, the classification of materials as nanoplatelets are effectively a next generation material, which we believe can enhance the different products and performances that people are looking for in rubber applications, including aspects of sustainable future. So basically looking at playing an increasing role in the sustainability and recyclability options within the rubber industry, particularly when you talk about upcycling. Upcycling being the sense of using materials which have been obviously around the cycle once and then recycled through the entire process back into industry, such as rubber tires or other materials which are forming second lives in the rubber industry in itself. And establishing this within applications, we're looking at the circular economy, which is becoming much more of an increasing feature that we're all having to deal with in different forms of life, but particularly if you look at the automotive industry in second generation tire applications. And then lastly, in SRMs, our second raw materials, which again focus on materials which can be brought out of the recycled products, such as recycled carbon blacks, which if you compare recycled carbon black systems, these essentially can be classified as 85 to 90% of what you classify as raw material, virgin material, which graphene is looking to enhance and support as the next generation carbon to basically look at uplifts in technical performance requirements. And it's an area that we're trying to focus our business model on and looking at the way that the industry itself is going. So a little bit more about graphene itself. So our graphene has a relatively unique footprint, fingerprint in applications. And you can see it's got a range of key property requirements across a broad range of industry sectors. So the focus for us as a business model is to talk about what we're actually looking to enhance in each and every application feature that people are interested in, whether it's in lightweighting, flexural strength, thermal conductivity, electrical conductivity, corrosion resistance, fire retardancy, and particularly in the tire in the rubber industry, issues around gas and water barrier properties, and physical characterization of materials and conductivity. And these are one of the key benefits of graphene we see is as a multifunctional carbon source material that can be utilized in a number of different platforms in different ways, just depending on what sort of materials you're looking to change and characterize within the structure of your formulations and end applications. So it really is tailoring those solutions to the problems or opportunities that you see in each individual applications that we're involved in, particularly if you're looking at rubbers, elastomers, and foam formulations, which while they cross over many different sectors, they also tend to refine themselves based around the same type of polymer designs. So we see that graphene could be utilized in a number of application features for each sector that we're working in. Okay, so a little bit about First Graphene. So First Graphene is an Australian company. We're actually an ASX listed company, so we are PLC. And we classify ourselves as one of the world leading graphene producers, and we manufacture our material in a place called Henderson, which is in Western Australia. And we are also a global member of the Tier 1 partner of the Graphene Engineering and Innovation Centre in the Manchester, UK. So we have a technical innovation centre in the UK and a manufacturing base based in Western Australia. We're also involved in the new substance registration in the UK for REACH, Europe, REACH, different classifications, but essentially the same process. Australia and the AICIS is in place, and we're expanding our business model into the US with the EPA, because graphene is also being placed as a discrete chemical, so it's classified under different regulations based on aspects such as the multi-layering aspects of graphene as a single carbon source, which is basically one layer thick carbon, which has a very high aspect ratio. So there's specific regulations based around the classification of these materials, and we're actively involved in that as part of the consortium. And we're also an active member of the ISO Standards Committee, which is looking at registration of graphene in application, but also in standardization of the material in terms of how it's classified, because we appreciate in the last sort of 10, 15 years, there's been a bit of a confusion in the market about the different types of materials that you can actually utilize or are called graphene, whether it's, as I've said already, monolayer systems, multi-layer systems, graphene oxide, or other types of materials which are associated with this particular industry sector. So we're in the process of trying to ratify that and conclude that with the rest of the partners in the graphene world. So what we do effectively as a business, we produce in high performance, high quality pure graph products. We have a current manufacturing capability is 100 tons, which is a modular manufacturing unit, which I'll tell you a little bit more about. And that is built and operational today. So we are in the process of producing materials on a regular basis and delivering requirements on a global footprint, predominantly from our base in Australia, but we're also looking at stocking points in various regions. And we work with a number of partners through our collaboration agreements where we can establish products and product criteria, product locations in the US, product locations in South Africa, in South America, and also around all the Asian subcontinents. So we're looking to support the industry on as wide a scope of a geographic term as possible. What's the outlook for us today? Well, as a business, we basically reckon we've banked the whole process of actually how we make graphene. So we're very much focused on the commercialization of the Pure Graph brand. And really sort of part of the reason I joined this business was mainly focused on the commercialization of the Pure Graph and how we're actually looking to push it in the different sales sectors that we're operating in. We have a segment focused business model. So I'm specialized in the class of rubber elastomers and foams. We're also in the coating applications, coatings and inks. We're into our largest sector at the moment is in concrete and some cement materials. And then we also have energy storage and also composites and plastics is within the full criteria of the graphene world, because graphene has a multifaceted application, and therefore in terms of industry sectors we tend to cover quite a wide range of applications. What we're looking to do at the moment is accelerate the global adoption of graphene, which, to be fair, the whole graphene world is trying to do, because basically when it came out of academia and we're following the industrialization, it's very much on the sort of early adopter into mid-scale, full-scale production of graphene has been the first endeavor. And the second part is really talking about accelerating the global footprint and commercialization of graphene in its current form, as well as future forms of materials that are likely to come through based on industry demand, because a lot of it has to be based around what is the industry looking for. And so we're looking to leverage our own proven experience, but also learn from others. So we're part of the Graphene Council. We're also part of the greater global graphene community, where we're looking to share ideas, share platforms, leverage technology, license technology where appropriate. I shared with Param before this presentation that at the moment, people, just as a bit of a general awareness, there's about 274,000 patents written about graphene in all forms. And there's about 1.4 million papers written on many subjects about the graphene technology. So we're fully aware that there's a large commercial interest. It's just more about adapting and changing that interest into actual commercially driven business models. That is our focus as a business today. Okay, so here's a little bit more about how we make graphene. So we actually make it from what we call top-down process, because there are a couple of methods you can use. You can use top-down or bottom-up, as they're described. So top-down, we're basically taking refined or veined graphite, and we take it through what they call a chemical exfoliation process, which is a sort of fancy phrase we're talking about. We're putting it in a large acid bath and have electrical anodes and cathodes in those systems. And within that product design, we're able to produce high quality, high yield, we're very low waste graphene of multi-layer material. So layer between 5 and 8 is our standard model of business. And we have that on a modular format. So the modular format meaning that that material is set up so we have a full quality control Six Sigma system in place. We have online testing, reproducible standards, and quality is definitely the key to our model structure from the manufacturing of graphene. So we have a range of systems that we put out into the marketplace that are controlled under these conditions. And that modular design is modular by nature because we want to be close to customer. So our current system set up in Australia is on a reproducible basis, able to travel wherever the supply and demand requirements are in the world. So for a relatively small asset in capex, we can set up this material so we can have another 100 tons in any given location that people are looking to support these in various industries. Okay. And then just to give you an idea of the type of cooperation that we have within our own structured business, if you're looking for materials which are outside of the graphene space specifically, so in other words, materials which are not just directly the powder itself, where we're also working with industrial partners to bring new products to market. So these products can be either of industrial interest, academic solutions, or we can look at obviously mobility within our value stream in terms of how we're supporting these products come to market. And if you look at the partners we have, some of them are international collaborations. So working with Fosroc, for example, and Breeden on cementitious applications, bringing those to market. And we're also working with Hubron and other master batching materials that can also bring semi-finished goods to market, specifically for the rubber industry or plastic industry. And if you look at the range we have in graphitic materials today, so we've got these powder materials, which I'll tell a bit more details about. We have our aqua grades, which are 80% aquatic materials, so 80% water, 20% graphene as a paste. We have master batches, which I'll share a little bit more information about. We also, in terms of our development cycle over the past few years, found much more interest in people who are interested in us pre-dispersing materials, which makes them easier for industry to use. So, for example, certainly in the rubber industry, process oils, which often find their way into the same market space, we can put pure graph materials into a process oil and make it more user-friendly from a mixing perspective. We have plasticizers, which we can also utilize in the same process. And with other polymers, we can use specialty polyols or even amine-based dispersions, which can then help formulators utilize the graphene materials into their applications, which hopefully just makes them a little easier to use, but makes them more user-friendly from a final product application in terms of how they've developed the technology and how they actually work in a given application field. So whether it's through a machine, hand mixing process, or whatever works from the customer's point of view of how we can actually develop the range of products that we have available for them to test. Okay. So here's a little bit more information on the graphene itself. So we mentioned already that we're obviously manufacturing quite high tonnage of these materials, and we manufacture in a range of what are called lateral sizes. So lateral sizes is basically because the material itself is multi-layer, so 5 to 8 layers, but it's one atom thick. So it's a one atom carbon ring, hexagonal rings, which are then laterally formed in different ranges between 5, 10, 20, 50, and we now have a new system coming to market at 70 microns. So that describes basically the lateral width of the materials versus the one atom thickness. So that's where you get your high aspect ratio and reinforcement of those materials. And those are averages over particle size distribution, which, as mentioned, through our quality control procedures, we can offer full CNA reports on those, and as required, we can obviously give people more information based on our own characterization of those materials. They are easily dispersed, but we make them easier to disperse by offering different options and solutions, such as the aqua, which is basically a material which is already in a paste form, which can be used rather than a powder form for various applications depending on the design. Okay. Here's a little bit more on plastic master batching. So master batches we have available today, some of them being very common for industry. So LDPE, HDPE, EVA we find particularly useful for the rubber industry. Some people, obviously, it's a material that you can combine with a lot of other materials depending on the criteria that you're looking to put into the end product. We've got polypropylene as well, and PET. We're also working on PA6. We're working on other materials that we're obviously looking to bring master batching systems to market. And the reason we're doing this is really just sort of non-intrusive for people's standard materials that they're looking to actually put into practice. So rather than having a material which is non-standard for them as a processor, these materials become much more about standard materials that they can utilize. Obviously, it removes the need for extra processing condition. Obviously, what we're looking to do is provide increased performance benefits, whether it's thermal conductivity or mechanical property requirements, in exactly the same formats that we would look at in liquid dispersions. Okay, so here's a little bit more about the areas that I'm focused on, which is the rubbers, elastomers, and foams. As I said already, the main question for me when I first joined graphene was understanding what's the actual practical use of the material and where do we see the most benefit is likely to come from. Within rubbers, we believe it's alternative to, as we mentioned already, to carbon source, because I'm sure you guys are all more than aware that carbon black has been the industry source material for a long time now. And there's other carbon products which have been used to reinforcing materials in most forms of natural or in the synthetic routes to bringing rubbers to market. And what we're looking at there is enhancing the wide range of industry targets in sustainability and some areas of smart solutions. Because previous presenters in these programs have also presented the idea that you can utilize the electrical conductivity of these materials of graphene in these particular applications that may be of interest in developing unique solutions to some, shall I say, new problems that will present themselves when you look at the electronic vehicles that are going to come to market or increasing their market potential across the world, and whether graphene and other materials can obviously bring those products alongside that, which will help and benefit that technology transfer to the next evolution of being environmentally friendly and hopefully emission free. And if you look at what we're looking at in terms of partnerships, we want to work with the different elements of the value chain, but we're certainly after targeting technology owners. So those who want to get the best value from these materials and what they're actually looking to achieve to do with them, which means that we can work with either the formulators who are interested in actually the compounds themselves from the initial standpoint in the value chain, or whether you want to talk to the compounders who are just simply interested in compounding the material into the rubber systems. And then obviously bring along the end users in terms of how they can utilize the technology to better get the full potential for the material in its end application use. A similar story really from an elastomer perspective, but elastomers we were focused on wear resistance because we have, which we'll show you later, we had some interesting early adoption into the mining industry. We've also got polymer improvements which look to enhance gas and vapor controls for energy and material storage. Which is becoming much more interesting technology base that people are looking to develop, predominantly based on new controls based around which energy choices we're making in the future, so such as hydrogen or other polymers which are looking to close the gaps as far as the actual materials themselves and being able to control the emissions of other materials. What we're looking to target there is OEMs, so people who are originally manufacturers or manufacturers who are interested in developing the technology into this space, but also working with formulators and system houses who are obviously looking to enhance their own product portfolio to better utilize the graphene technology. And finally, foams. We believe it's lighter, stronger, and resistance is what people are looking for. There is some stats out there that you can all read, which says there's about 6.2 million cars have already got graphene in various forms, whether it's in lightweighting applications for foam or whether it's in other materials and plastics. And we're looking to develop partnerships and relationships with the OEMs and downstream users, industrial tier 1 manufacturers and automotive specifically, because that's where we see we can utilize the technology space of graphene in its best form to be able to get to actually the right key points to turn the technology into a transferable skill and transferable material into the end market application. To give you some rough numbers, what we look at is an established addressable market. We would suggest there's around about 200,000 tons of graphene potential in this particular market space. So that's current and future potential, and that's what we're looking to target as a business model going forward from here. Okay, here's some practical examples of early applicators who've actually utilized this technology. So we've got a company that works with in Australia called NewGen, and they brought to market a product called Armograph. So Armograph is being more utilized as a rubber abrasion liner, predominantly in the mining industry, but we're also finding it being adopted in conveyors and other application features. And there's new products coming out all the time that are real life tested in these particular applications, because that's where we do see the value proposition in graphene, is in the sense that once you've actually put it into a final application and done the study to see how well it compares and contrasts with the well-known industry standards, that's where it tends to find itself being of primary interest, because in the end, once you've got the information, this material can last 4, 5, 6 times longer in some cases, depending on the application features. And that's really the area that where the product itself is starting to actually sell graphene in terms of material usage in long term. Second element we've got working with is this company called Steel Blue, who are a footwear manufacturer. So in footwear, they're focused predominantly on 2 elements, which is either lightweighting, so actually making comfortable footwear for the heavy industry. So if you're actually wearing working boots every day, you might find that a reduction in weight will be advantageous and obviously make it more beneficial and more comfortable. Second element is abrasion characterization and materials lasting longer. So value proposition there is based on how long you can actually use a given footwear in a given application, and really focused around how you can get best use of that material. Final area in this one is wheels. This is an early adopter program that we're working through at the moment, where we're characterizing graphene based on its abrasion resistance in heavy duty segments and applications, particularly in the mining, steel and paper production industry. We're going through the process of development, and we're hoping to be able to bring products to market in terms of named materials that we are associated with this particular industry. Stator elastomers is another area where we're actually looking for oil and gas industry. There's already products out there in the market space, and we're looking to develop that technology into the second phase, which is really talking about heat resistance and heat characterization resistance over long periods. So we're looking at data points to understand what is the true benefit of utilizing graphene. We're hoping to be able to bring that information in the coming months. The next one is workwear gloves. So workwear gloves here, we're looking at lightweighting or impact resistance, and really there is a measured benefit of understanding whether you can utilize graphene in certain applications for workwear, because there are already graphene gloves in the market space that people may be aware of. These aren't graphene gloves that we're specifically looking at, but we're looking at different elements of the gloves to give them lightweighting options and impact resistance, which makes them more comfortable to wear and more user-friendly. And then the final area, which utilizes a different technology branch of graphene, is in insulation. So in insulation, whether you're after something with some materials which are classified as more user-friendly, because a lot of chemical legislation is coming into effect and it's continued to pressurize the industry to move in a slightly different direction when it comes to the choices they make from a fire retardancy perspective. And here graphene is looking to enhance certain materials, whether it's a polyurethane, PIR, XPS technology or other associated rubber materials, which can be utilized for insulation. And the natural benefit of using graphene is in fact the material itself is naturally expanding. So it actually expands under heat around 300 times the standard, which is well known from its graphitic technology base, but moving into graphene, it's becoming a material which can be utilized more readily in these materials and still offer the same or similar fire retardancy applications under testing. Okay, and a little bit more of a history of graphene already being fully adopted in the rubber world. So if you look at G Ultra efficient tires in 2019 when they were launched, You look at Vittoria tyres in February 2019, and Goodyear tyres have actually started to adopt the use of graphene on a more regular basis. The predominance of what these guys seem to be interested in fact are repeatedly promoting to market, is they're seeing, again, the characterization in use. So it's an increased life, so less wear, equating to longer intervals between changes. So typically, if you're looking at your tyre changes, which can be in the UK standardised at between 20 and 30,000 miles, you could actually find there's more efficiency in extension of those life. In bike tyres, it's much more about performance and how long those materials will last. And given the fact that we've got obviously long tours in Europe, that the elite areas is where it seems to be adopting the most interest. You've got enhanced speed, there's reduction in rolling resistance, air retention, which is the gas barrier properties for nitrogen and air, which again is showing the multifaceted nature of graphene. Grip, which is dissipating frictional buildup through thermal route, so thermal dissipation, and cut resistance, which is predominantly focused on mechanical reinforcement. Okay, and one of the final things I'll mention is that the observation I've got about graphene world, and I use this analogy with Param recently, is that I think because the graphene itself was born in Manchester or discovered in Manchester, it's a bit like the Man United football ground at the moment. It's got 57,000 people stadium. Everyone seems to have bought a ticket. There's quite a few people obviously engaged in the process of graphene, but effectively there's only seems about 11 players on each side, and there's about 3 or 4 of those who actually are putting a lot of material and a lot of fund in the game. And at the moment, if you consider what's out there from an IP perspective, Goodyear, Michelin, they all have patents filed. So some in 2019, some in 2020, where they talk about low frictional graphene rubber compositions or surface functionalized carbon allotropes in tires. And again, it's looking at increased stiffness, reduced hysteresis, abrasion resistance, and reduced coefficient of friction. And a lot of these technologies transfer of what graphene can do is well understood, well versed. It's really just waiting for those markets to really take them on and take them further into the future. Okay. And finally, I'll mention one area that I think the fellow speaker knows a lot more about than I do, oxidative effects, which is partial replacement of antioxidants to increase life. And this area where it's more about the behavioral characteristics, which is associated with materials which are under review from hazardous nature. So materials which are utilized in formulations which can effectively need to be replaced at some point. And there are endeavors that graphene itself could offer some benefits and potential solutions. And the Black Cycle movement, which is a big European move towards higher use of recycled products within tire and non-tire applications, is a legislation which is coming into bear, which is talking about introducing mandatory requirements particularly for automotive, but also non-automotive rubber applications, where you're looking at, automotive tire applications, the minimum requirement to put 10% of recycled materials back into the tire. And then in the non-tire applications, up to 20%, which is a challenge because in the end, a lot of performance criteria, particularly when you think about it from a safety perspective, it's quite a big challenge to make sure that the materials which are coming back into those markets are of the right quality and standard. And what graphene's looking to offer is a potential solution to help bridge some of those gaps. It's still early days and it's still understanding what's actually going to happen in the future. But where it is right now is that graphene can certainly be one of the considerations of the next generation carbon, which can be utilized in these particular areas of industry. And there's plenty of others and examples I could talk about all day, but these are the main ones I wanted to sort of communicate, give more information about. And if if there's further questions that need to be asked, we are more than happy to help going forward from here. And that's it from my side, Param. So feel free to contact us either in Australia directly, or you can contact us in Manchester, or I can obviously offer all my details and contact details so you can contact us directly. But feel free to look at our website because we are a PLC You tend to find most of our information is on there, and we will share as much information as we can. Okay, and thanks very much for your time, and now open to questions.
Thank you, Peter, for the informative presentation on the graphene. Okay, please stay on. Let's go for, we have a discussion session now. Thank you very much, Peter, once again, for giving us informative presentation on the graphene and what applications are there for rubber industry. I think a lot of opportunity to explore. Yeah. So now we get into the discussion session of this rubber industry tech talk. I'd like to invite Dr. Brendan Rogers. He's a rubber industry consultant with 45+ years experience in the rubber and tire industries. He also worked in the graphene as well, and I'd like to tell you that he wrote two good books for the benefit of the rubber industry and the tire industry. And we check the CRC Press, their website, tire engineering, and also the rubber compounding. Dr. Brendan, please come forward.
Okay, I'm back online.
Yes, sir. Welcome.
Okay.
Now I invite the next panelist is Mr. Alan Whitley. He's a technical manager at the Fluid Compounder based in UK. Alan also has a 25 years experience in the custom rubber mixing and compounding. And I understand that Alan and the Fluid Compounders working together with the first graphene and developing the various compounds. So Alan, please come forward. Welcome, Alan. Let me unmute your speaker. Okay, super.
Thank you, Prem.
And the next panelist, the final panelist is Mr. E. Palanathan. He is also well experienced rubber technologist based in India. He has also close to 35+ years experience in the rubber industry and the compounding processing. So welcome, sir. You can call him shortly EP. So guys, you're all here, 4 of you with huge experience in the rubber industry, tire industry, and also with the graphene. The floor is yours, and with just one ground rule, make it a lively, informal, informative conversation about the graphene, everything about the graphene that the industry should know about it, and what's applications, what are challenges, technical issues, and there. With that, I invite first Dr. Brendan, pose, start questions or, some intro to the, please.
Well, thanks for the invitation to participate. Peter, that was an excellent presentation, very informative. So thanks for pulling that together for us. The graphene, I agree with you. This industry is relatively young. It's going through an evolution, very rapid growth phase. It's going to be interesting to see how it plays out in the next 10 years or so. But I think you had alluded to a point. This was essentially a pristine graphene as such. We believe that there's fundamentally 3 types of graphene that are out there. There's a graphene oxide, there's reduced graphene oxide, then there's a pristine graphene oxide, and all 3 have got different levels of functionalization on the plate surface. What does your grades of graphene fall within? Does it fall within that sort of spectrum, or is it unique yet again in terms of its chemistry?
Yeah, it's the reduced graphene oxide. I would suggest, Brendan, is that it's hard to characterize, as I'm sure you're well aware, from an oxidation point of view, because graphene, in terms of its purity, if you think about monolayer graphene as it was advertised, used manufacturing CVD methods. So the bottom up process, which I didn't really take a lot about, really, if in terms of characterizing multi-layer functional materials, then the oxidative or oxygen levels that were in those materials are difficult to quantify. But we are aware that they are there. There's a presence of them, but it's essentially how much is in there and what effect that's having. I think what we can definitely say about our materials is that through Raman analysis, which are the typical methodologies used and agreed, and if you look at the standardization or the specification that's coming forward from the Graphene Council, I think at the moment there's still a lot of endeavor to make sure that the standardization of the graphene itself is clearly understood and also clearly communicated to market. The reality of that, as I'm sure you well know, Brendan, is that if somebody has to pay for it all at the end of the day, and somebody's actually got to put all these bit of information together. So I think what we're trying to do as an industry at the moment is make sure it's fair and make sure that the information sharing is open. So if you look at the, like I said already, with the EU REACH regulation, UK REACH will be the same, all REACH standardization. I think at the moment in Europe, for example, graphene is classified as anything that's less than 35 layers. We'd like it to be less, to be honest.
Yeah.
And that's not just from a selfish point of view. It's mainly from the distinction that what we find is if you compare and contrast in a test, then of course each of those different types of graphene will have a different result. So what we're keen to characterize is to say, okay, what's going to give us the right consistency when you compare and contrast based on the different applications that you might want to look at. So whether it's, like we said, a synthetic rubber or natural rubber or any other types of polymer, is if you're getting a fair answer at the end, then I think that's all that people can expect. I think it's just making sure that the answers are clearly understood.
Yeah.
Does that characterize it in your mind?
Oh yeah. Yeah, one thing was puzzled us is when you the more chemistry that's on the surface of the plate, the more it's going to impact the vulcanization kinetics.
Yeah.
And the more it impacts vulcanization, then there's more compound development work involved in its implementation, either in tires or industrial rubber products. So it's always an issue. What's going to be, how will the vulcanization be impacted? And of course, the mini viscosity as well, when you look at rubber nanocomposites. So yeah, that's an issue. So some graphenes that are more pristine are drop-in, some that are functionalized, it takes a little bit more work to optimize the formulation for whatever property is being targeted. So
yeah, and I think it's fair to comment that the next evolution, I think, is it's coming to market, because we were at the Advanced Materials Show, which is a meeting of all the guys from the graphene world a couple of weeks ago in Birmingham. A lot of time was spent on commercialization and discussion around how you can actually get these products to market. And it was seen that functionalization is possibly the next route. Because if you look at people who are doing it either from a chemical perspective, so chemically treating graphene, or other methods that you can utilize to create some sort of functional group within the structure of graphene itself, then, like you said, as long as it's specific, as long as it's understood and clearly communicated to customer, which I do find the biggest challenge, because we can all do what we want from a chemical perspective, really, but it's making it more user-friendly for industry, which I find is the greatest challenge. Because old rubber guys, I'm sure you know from the many years they've been working, they all have their different methods, slightly more or less on the same themes, but slightly different ways of doing. So, creating that product which is, like, so we say, universally accepted, is a definite challenge. I think Alan may agree on that one, because I think you've tested enough of them over the years.
Quite a range over the years. So, I mean, that would probably be my next question, is, like you say, we struggle to disperse some of the materials and that, and it's a variation in results, whether it's mechanical properties, electrical conductivity, thermal, like you say, gas barrier. We tested for loads of different things, and sometimes it's inconsistent results. So do you think that is down to dispersion, or could it just be consistency of the material because they are quite new at the moment?
I think it sounds like a political answer, this one, Alan. I think it's a combination of both, to be honest. What we found from a compounding or dispersion perspective in the early days was that was seen as the primary issue, because basically, think about graphene from its origin for us as graphitic product, we spend an awful lot of energy, a lot of time actually separating out the layers. So reducing agglomeration is the mantra of our business model. So taking graphite and basically dispersing it and keeping those layers apart is the fundamental of how we actually generate graphene in the first place. So therefore, any process which then helps with continuing that dispersion or making sure the products don't agglomerate is, of course, key to making sure the products work in a given application. And unfortunately, in compounding, as I'm sure you guys know, so sometimes you've got multi-stages, so it's not just one stage. You know, whether you're using a Banbury mixer for internal mixing, roll mills, other applications that involve multiple steps. That's where sometimes also you can accidentally cause re-agglomeration, or you lose that dispersion in another process step. So we understand the challenge, Alan. I think some of it we can help solve. In other areas, it's almost impossible for us to solve because in the end, there's only so much we can do.
Yeah.
But, I mean, the truth of it is, what we found is the particle size is definite key. So depending on what sort of particle size of materials you're using, so whether it's say average 5, 10, 20, 50, 70 micron lateral, because you have to think about the lateral aspect ratio of the material, how wide is it, and how much is that reinforcing in a polymer structure. And I think then the second part for us is then talking about, okay, utilization at a percent. So what percentage are people willing to put in a formulation? And before we start the commercial discussion, let's talk about it technically. So technically, we see an optimization between 1 and 10 pHr is the right sort of levels. Above 10 pHr to 20 pHr in whether it's a natural rubber or synthetic rubber, you can actually start creating a negative effect, and that's purely technically. It's not just commercially. Because we're seeing some of the benefits of using graphene can start to degrade in terms of physical reinforcement, for example, or other because you basically got a higher aspect ratio carbon, which is obviously causing other issues as far as reinforcement potential. So I think it's a case of targeting the right amount and then talking about obviously the dispersion itself. What choices do you have?
Yeah. So that's sort of, like you say, you're thinking carriers, master batching, that type of thing, like you're saying, about that as well.
Yeah, well, I think what we've done that for two very good reasons. First of all, some of our customers said, I'm not putting a powder in my material. So, okay, that's a simple answer to a question. If they won't put the powder in, then there's nothing you can really do from trying to sell them a powder. But in essence, actually, it was partly to solve the first point, which is how do we get our material well dispersed in a medium to a customer, and then make sure that medium is suitable for their formulation. So that's I think that's where the industry is heading, Alan, and I think you've done enough testing with graphene to understand why we're doing that.
Yeah, exactly. That's fine. Okay. Just one other question on the thing where you mentioned about graphene with recycled carbon black. Similar sort of thing, putting in sort of low-level load-ins like that just to gain some of the properties you might have lost back. Is it that's something you're thinking?
Yeah, I think with the quality of the RCB movements changing, I think you guys probably know better than I do, is that the sort of the pyrolysis method of like getting carbons back out of vulcanized tires, for example, because as you mentioned, Brendan, the biggest challenge tends to be, well, okay, what happens to that extra bits of sulfur and bits of other materials that are in there once they've been pyrolyzed back out again? And the RCB movement seems to be suggesting they've got the quality right. It's more than they haven't necessarily got exactly the same performance you would expect from virgin carbon black today. So it's a bit of a marketing thing, but it's also a practical reality thing. If graphene is seen as a material which can take you from 85% to 90% to what you normally achieve with carbon black and take you back to 100%, then of course that's a big win for both in the respect of materials which are required in the industry, as well as obviously materials which could be enhanced. But I don't know, Brendan, maybe you got more of a view on that one because you're the one who's closest to the tire industry from my experience.
Well, there's been you'll always have this ongoing push for both post-industrial and post-consumer recycling back into original products. You know, when you cut to the chase, at the end of the day, when you recycle, performance goes down. So with the existing technologies anyway, and people have tried all sorts of things trying to enhance the properties of recycled materials, but you're still dealing at the end of the day with a heterogeneous material. Carbon black is very homogeneous the polymers are homogeneous. When you look at a recycled material, whether it be carbon black, quote unquote, with all the other things that are there, it's still a variable. And you know, I've always felt, you know, the best definition of quality is consistency. And if the manufacturer, the tire companies, or the industrial products companies could be assured of a consistent material, then I think it's workable. But that variability is there, and that variability is going to be a function of the feedstock. And every tire is different, so we get that fundamental variability. That's going to impact the consistency of the quality of the final recycled product, and then so overcoming that is going to be the challenge. But then of course the impact on the final product performance. So like here in the US anyway, the retreaders, for example, truck tire retreading, they'll have a X% of recycled material back into the retread, maybe 3-4%, and you know that's okay. They can get by with that. It's fairly dilute, but when you go to 10%, I could see the importance of material consistency being crucial to move forward. That any variability is going to have a detrimental impact on going forward. So if you have material like graphene or some new technology materials, that can open up an opportunity to address that variability that the tire companies could perceive or see. I think that's going to be a real issue if they have to go to 10% or so.
Yeah, and it's being legislatively driven as well, Brendan. That's the key to it, I think, because from what I've seen of the RCB movement, certainly the Black Cycle movement in Europe, they seem to be getting a lot more political weight behind it. Because in the end, particularly in Europe, as I'm sure you know, the economies, the way they've been going to be driven for the next sort of 10, 15 years is very much based around two fundamental factors, which is CO2 taxation and recyclable sustainability. If you haven't got those in your models, then I don't think you'll be doing much business in the Europe in the next 10, 15 years, to be honest.
Yes,
I think that's the truth of it.
Yeah.
Yep, that's a tough one.
You have something else?
Yeah.
So as regard to the 100-ton manufacture, what proportion is going for plastic? What proportion goes for elastomer?
In terms of our 100-ton capacity, you mean today? We've just done a new investor reach out for the last quarter. So at the moment, I have to say that the composites and plastics has the largest interest in the sector of graphene, although that will be quickly, we think, quickly taken over by concrete. We think actually the next big user of graphene potential is going to be the cement and concrete space. Just as a practical example, the Breedon project, which I mentioned to you, which we can openly talk about because it's it's no secret information. That's going to be a 30,000 cubic meter, which uses a reasonable quantity of graphene. So at the moment, I'd say that 100 tons could quite easily get absorbed within the concrete space really quickly. And then with the next generation for us will be more about, okay, the plug and play process that we describe of how we get more graphene to market. So, but I would say the plastics is slightly larger than the rubber. But I have to say one of the themes that I see about rubber, if you pardon my interpretation, is that the rubber industry has done an awful lot of testing with graphene. I mean, Alan, you'll know this. You'll nod your head because you guys have tested it to death. A lot of other industries have done exactly the same, but we haven't really found those, let's call it unique or USP requirements for graphene in a end use point of view. Because speaking openly, you guys know that graphene is not a cheap source of carbon. If we're comparing and contrasting with existing carbon black, okay, it's got a lot more expensive this year, mainly because of the Ukrainian war, which is a very unfortunate event, but it's created an environment where there's been a shortage of carbon black. But that increase is going from €2 to €4. So it's not a significant jump in actual material value terms compared to what graphene is from a commercial standpoint today. I mean, I don't know how much you guys want to talk about the commercial standpoint of graphene, but in terms of where it is at the moment, it's still in that, I would call it, semi-post-industrial phase of development. You know, we know how to make it efficiently. We can make it at scale. It's very much about the cost dynamics of how you actually get it to market in the end. Because I'll just give you a direct practical example for graphene. So our biggest cost of graphene is not the actual material. So the graphite, everybody knows, even vein graphite, you can quickly check what our more or less what our exact input costs of raw materials. We use an acid, so you know how much an acid costs. But in the end, for us, it's much more about energy. So it's higher energy intensive and time. Because time critical material productivity of graphene means it becomes a material which becomes inherently expensive, predominantly from a process standpoint. So as we build the industry, what will happen, of course, by nature, if we invest more in clean energy, cheap energy, that will answer the energy question, hopefully, in the future. And then if you talk about time, then for us, it's much more about the scale. So if you're producing graphene at larger and larger scale, then the economics can become more interesting, or shall we say, more interesting from an industry standpoint, because industry does not want to pay €1 more than they used to pay last year or 5 years ago, or in some case 10 years ago.
How about the standards, ASTM standard? When will hit an ASTM standard using the graphene by way of a characterization of graphene? As Mr. Ali was mentioning, I have tried about 3%, 5% of graphene and various polymers, and sometimes the results are very encouraging, sometimes inconsistent. So we are not in a position to take a very quick decision on this actually. So we keep experimenting. Actually, when it is standardized, the methods get standardized, the people will have more confidence to start using the graphite in the elastomer area. When will the standards will be ready for the public or for the technologist?
That's a good question. It's unfortunately still a little bit, how long is a piece of string, to be honest. At the moment, there's a lot of talk about it. There's a lot of development. There's a lot of characterization going on. But realistically, I think it's still it's certainly not in the month stage. I think you're talking a couple of years away before you actually get to full agreement, because the problem with the standardization, EP, as I'm sure you know, is not necessarily the actual writing of the subscriptive information. It's much more about the agreement process you have to go through to get everybody to agree, because that's the part that takes time, to be honest. So, but we're quite, we're busy pushing it through from our side of things. The Graphene Council is also doing their bit. So I think it will be, well, hopefully 23. But I would like to have said 22, but I think that's unrealistic as things stand.
Okay. Guys, some participants have posted some questions, so let's take some of these questions. Yeah,
sure.
I'm prepared again, so I'm putting on the screen. Look at them, and then I encourage every one of you to. Peter, like to take it?
Yeah, sure. I mean, in terms of the reducing rolling resistance, a lot of it is two aspects of graphene, which we believe is handling the rolling resistance, which is predominantly based around it has a natural tribology effect. So in terms of a material itself, it has, if you actually put it between your fingers, a lot of carbons, you tend to, if they're quite sooty, you'll tend to feel them, they're quite gritty. If you actually feel graphene itself, it feels a little bit oily. And that's just a description of materials which are comparing and contrasting plates with spheres. So if you think about a plate which actually forms across each other and there's very little frictional differences in performance, then that's really where you can see some benefits of graphene. And I think that also, another aspect in the grip side is talking about heat buildup and hysteresis effects, where you're actually looking at materials which can dissipate heat at the same time. Because as you're obviously materials which are going under high frictional forces of heat, either on a turning circle or on a general rotation, They'll also have materials which will be thermally dissipative, enhanced within the materials itself, so it can actually help form the polymer and keep the polymer at a certain status as you're going through those. But I mean, you're probably better off asking Brendan, because he's probably more the absolute expert on this type of question. So maybe you can help us on that one, Brendan.
Oh, well, I would never claim to be an expert, so that's
certainly more expert than me in that respect.
In this business, the more you know, the more you don't know. So yeah, this one is there's a lot of items, articles in the literature, some very good journals like Robert Chemistry and Technology, that have made claims around graphene, both improving rolling resistance, reducing it, and improving traction performance. I think it's going to be a much more complicated phenomena than what we might anticipate. It's not a drop-in. It'll depend very much on the chemistry on the graphene surface and how that interacts with the polymer, and then adjusts the tangent delta curve on the loss modulus of the compound. The pristine graphenes don't seem to have much effect on hysteresis. The graphene oxide would have a bigger effect because it's going to interact with the polymer. We're going to see more chemistry. It's going to affect the cross-link density, the compound stiffness, storage modulus, and that in turn is going to have an impact on the loss modulus, and then in turn the tangent delta curve. So I think this one is going to be a more complicated question than just a simple drop-in, as would be the case for other materials, like, for example, we look for barrier properties. There's all just an impact of the aspect ratio of the graphene plate. In case of rolling resistance, grip, traction, the looking at the tangent delta curve and the graphene impact on the shape of that curve, there's a lot more work to be done. And there's certainly, I wouldn't say they're necessarily conflicting properties, because sometimes increasing the tangent delta curve at around the height around 0 degrees centigrade doesn't necessarily mean that we're going to see an increase at 60 degrees centigrade or 30 degrees centigrade. So a lot more work to be done there, and I think it's going to be a function of the graphene type as well. So
yeah, totally agree. And also, one interesting aspect we've found from studies is that graphene has this ability to change TG within a polymer space, which is actually quite unusual for functional fillers, as I'm sure you guys know. So it has that, because it has that inherent ability, that suggests that effectively there is some reactivity structure that's going on that is changing the rubber property materials. So I think I'll definitely agree with you, Brendan. I think there's more work to be done on that front, which will help us clearly understand exactly what's going on.
Yeah, the tangent delta curve is a function of the TG. That's going to control everything. Yeah. So the more you can influence the TG, you're exactly right. I agree 100%. Yeah, that'll affect rolling resistance and traction.
Yeah, I mean, what I can say is that electrical properties have been studied in numerous studies, depending on the structures of the polymers. And a lot of it tends to be based on conductivity requirements in comparative nature, if you want to call it that, with other carbon materials. And this is where I would say there's a friendly space for graphene, because we've actually seen that if you utilize the variable sources of carbons available, you get the best balance of properties in electrical conductivity. So if you're looking at tubes, for example, which have been around for the past 25 years, because they came out as the wonder product 25 years ago, then you've got the plates, and then you've also got the spheres. And we tend to utilize a combination factor, which will give us different aspects of electrical properties that people are looking for. And to be frank, most people are looking for the lowest concentration you can put in a system for electrical conductivity purposes, because you effectively want to put as little as you can in to give the balance of properties requirements, if it's specifically only electrical. Alan, have you seen much on that front yourselves in electrical conductivity requirements?
Yeah, like you say, similar to what you say there. So like you say, and it depends, like you say, the types of graphene you're using and the form, and that seems to have big differences. So it's like you say, we've seen encouraging results, but I think it's now we're at that point where it's sort of like we need to start optimizing and start getting that type of project going now, isn't it? So we've tested enough things to see encouraging results in different areas, and now I think we're in that optimizing phase now where it's concentrating on specific problems and trying to solve them with the things we've seen, isn't it?
Definitely, totally agree. EP, Brendan, feel free to chip in if you want on this one.
I think this is a big one. Yeah, we've seen some of the data. I've seen, Peter, to your point, small amounts of graphene can have a big impact on properties. And we saw that with electrical conductivity, electrical resistivity. And that's kind of an interesting one because here in Texas, along the Gulf Coast, there's lots of oil facilities, as Louisiana, across the Mississippi. There's some very, very large refineries, and there's oil moving back in tankers along Interstate I-10, the main highway. And one issue that comes up periodically is electrostatic buildup on the tires. So if you've got a 53-foot trailer hauling petroleum products and you have electrical buildup on the tire, then it's our static buildup. Obviously that's not desirable. So small additions of graphene can really have a big impact on reducing the electrical resistivity, increasing conductivity. The big issue is going to be the percolation point. And what is the bigger the graphene plate size, the lower the percolation point. And then with carbon black loaded compounds, the very little is needed to get a conducting path, particularly with carbon black. Silica is more of a challenge. Silica treads, the so-called green tires, that's much more of a challenge since the need much higher levels of graphene, and then it becomes cost prohibitive. But this is certainly one application that I think has got a lot of potential in tires, and then of course the electronics industry is another that's wide open there as well. So
absolutely. Some more questions, Bram, or do we? Okay, so I think we sort of handled this one to some degree already. I think it depends on the systems, of course. It's always all dependent on the systems, but typically the dosage rates, we're looking at between 1 and 10 PHR, but that's realistically looking at replacing existing carbon black. So if a typical carbon black compound has 40, 50 PHR in a standard formulation, for a tire tread, I mean, I'm not sure if they're that high these days, but if they're, depending on whether they're synthetic or natural, then realistically with graphene, you're looking, say, to be effective above 1%, and then typically less than 10 PHR. Is that sort of areas you look at as well, Alan, Brendan?
Yeah, that's about right. Yeah, we find, again, it's going to be a function of the aspect ratio and how well it's dispersed in the compound formulation. But anywhere between 1 and 4, 1 and 5, we're in that window. 1 and 10, it's the same. And certainly when you get up to 20, you see that drop off. Yeah, that's very consistent, remarkably consistent. When you get over like 8, 9, 10 PHR, I'm talking PHR here. Okay, weight percent divided by 2 roughly for the sake of round numbers. It's when you get up to 10 PHR, properties really do tend to drop off. So it's
an interesting point we've seen is that that's also independent of carbon black being in the same formulation as well. So even just graphene on its own, we've seen that above 10 PHR can be, well, above 15 actually, 15 to 20, we started to see a performance drop off just with virgin materials and graphene itself. So there's definitely a fine balance to be had between the maximum material you can load into these products, depending, like you say, on the aspect ratio.
Yeah. Well, when it comes to teaching graphene use in rubber nanocomposites, we would always say that you treat graphene as a compounding additive and not as a replacement for carbon black, because it's very, very different. Very, very different. So it's an additional compounding tool, but it's certainly not a replacement for carbon black. You're going to negate a lot of the advantages that graphene will bring to the table by treating it just as a replacement. So you know,
So,
we would
totally agree.
yeah,
Totally agree, of course.
it's an additive. It's a high performance. It's a high performance additive. In reality, that's what it is.
Which makes its cost a bit more acceptable than as a filler, really, doesn't it?
Well, it's yeah, okay. You always have the cost
Absolutely.
issue. It's a very sensitive industry. It's cost sensitive, but again, it's the type of properties and improvements that this brings are not attainable with carbon black. You can't get it.
Yes.
Permeability, the tear strength improvements, the abrasion resistance improvements are not attainable with carbon black. So it is very much a high performance additive.
Yeah, totally agree, and it's one of the compounding questions we always get, because as a business, we're trying to justify the cost of graphene based on its alternative to other carbons. But in the end, you're absolutely right, Brendan. What it needs to be looked at is in isolation for itself, and it's, as we said already, that will become more evident as the industry grows, because in the end, as the addressable gap on the cost differences becomes more, it's certainly never going to be acceptable in my view, because nobody wants anything to be more expensive these days. They all want it to be cheaper. But the reality is the addressable gap will be less of a challenge, but it will still be maintained as a challenge because it will be a high value additive compound. Yeah. So Eve, you wanted to comment?
Is this graphene anywhere tried in the sealing compound? For example, in the case of a dynamic shaft seals and all, we look for some various lubricating agent, molybdenum sulfide, graphite, and PTFE powders are being used for reduce the friction. But is there any industry tried out using the graphene to minimize the abrasion or improve the wear life? Any of this application has been tried out in a non-tire, especially in the shaft sealing applications?
Yeah, I think what I've given the presentation is probably something similar with the stator elastomers. So if you think about a stator, which is used in drilling compounds, so if you've got obviously looking to extract and pump hot oils and hot drills, oil and gas, then that's where graphene can be utilized. Predominantly for me, it's two areas, which is thermal dissipative behavior as a material, because it can reduce your overall operating or resistance to your material for longer periods, is what we've seen. In fact, we've done some studies on soaking the material at high temperatures. So soaking means standard industry oil or water. So if you take those to higher temperatures, so 120, 150, 170, typically your rubbers will always degrade. What we're finding is, interestingly, the graphene will actually reduce that degradation. So we're finding the actual material itself is actually protecting the rubber and polymer structure by enhancing its thermal decomposition characteristics. A second point being tribology. Itself as a material is interesting in the respect of it does have that natural lubricative effect, because it's actually also being looked at thermal transfer fluids. So people are actually using thermal transfer fluids, are looking to put graphene in those fluids, which will ensure you get a good path of heat transfer. So if you're talking about transferring heat from one source to another, then that's another area that you can utilize this type of technology.
Okay.
Yeah, I think the antioxidant is quite a good thing, like you say, and a good opportunity there, isn't it? Because some of the restrictions that are coming in on a lot of their materials, it could be a good area.
Yeah, well, that's what I'll definitely hand over to Brendan, because he's the expert on that one. I mean, I hope you don't mind, Brendan, because I did use a source thing. If you look to the bottom of the presentation, the presentation was specific for the one that you did in Ohio. So yeah, I hope you don't mind that was definitely in there as a reference point.
Yeah, that's absolutely fine. Thank you. Thanks for using it. Yeah, we're doing another one. Yeah, the follow-up to that paper that was given in Cleveland. The next rubber division meeting will be in Knoxville in October, and we're doing a follow-up to the to that paper. The focus there was on the optimization of the 6-ppd, the anti-ozonant, and the antioxidant levels. So graphene looks like it can certainly replace the antioxidant and most of the anti-ozonant. Replacing the anti-ozonant is going to be tough. It's going to be a tough one. Yeah. But if we can cut back 50%, 70%, that would be great. That'll be a huge step forward.
Yeah, definitely. And do you, I mean, I know your paper goes into quite a lot of detail, Brendan. So I think most of our audience would appreciate a copy of it when you get a chance. But I'd say to you that it'd be interesting to understand exactly what is the mechanism as far as you can characterize it in your mind.
Oh, I think you know, those 6-membered rings, carbon rings with with electron clouds, you know, the pi cloud. Now that's going to be a free radical scavenger. Yeah. So that's the first thing. Anions, cations, yeah, it's going to capture them all. So you know, there's a lot of sort of simple cartoons and a lot of the journals, applied polymer science, that basically shows schematics of the polymer chain, functional polymer chain or severed polymer chain, being stabilized with the C6-membered carbon rings. So, and that's, you know, that's your first year college organic chemistry. So it all makes sense. It's a very plausible model. But basically, we see it as a free radical scavenger that can neutralize cations, anions, both. So it's you know, that's the fundamental mechanism. And these plates are so big, and they exfoliate so easily that it's you can see that if there's a dispersion issue, yeah, we've got a problem. But since there's not a dispersion issue, they exfoliate, and it's easy to visualize that qualitative model as a result. And that's both as an antioxidant and as an antioxidant. Even hydrogen permeability, it can absorb hydrogen molecules permeating through a rubber matrix. So it's same thing.
Yeah, absolutely. And I think also what's interesting, it's not just for the very expensive car market, Brendan, from what I've seen on your promotions. You know, it's not just for obviously the Lamborghinis where they're looking to keep the nice sidewall black for longer terms of period, when those Lamborghinis only come out 3 times a year.
Yeah. Yeah. I remember when I was living in Shanghai, there was in the basement, there's some very expensive cars, and there was a Lamborghini down there, and it was a beautiful car. But you know, it was $1 million vehicle, and so you know, I wonder if they were very meticulous in how that car looked, and the tires had to be spotless. So no brown stains.
No brown stains, no crazy, no cracking. Absolutely. Sorry, Param, I think we missed one of your questions. I think you had one for master batching, was it?
Yes, that's right.
Well, yeah, I think I advertised the fact we've got an EVA master batch, if that's what the question means. So, I mean, we've got a compound that you can use as a master batch within some rubber compounds, but some people don't like using EVA. They prefer to use their own material. So what our general model is to talk about people's own use of either synthetic or natural rubbers. So what we would always say to them, look, if you want to actually pre-master batch the material in, we offer that as a service. So we can actually take the base polymers that you're putting in your formulations and actually disperse graphene in those materials and then further compound it into your products. And typically, just to give you some ideas, we normally talk about around about 30 to 40% is the maximum we can compound in. So that's the sort of levels that we could pre-compound the graphene into let's call it a typical master batch, as it's characterized and described. So hopefully that'll be useful information. But I'll be honest with you, what we tend to find from master batching, again, it's all down to the multi-stages of thereafter. If it's a one-step process, that's where you can sustain the property requirements you'll get with graphene. If it's a multi-stage process, particularly in compounding or extruding or other processes, compression molding, whatever it is, that sometimes can have a negative effect. I don't know if you said that much, Alan, from when you've been compounding it.
It's something we're noticing, yeah. So like you say, initially you always think add another stage to improve the dispersion, but we're getting hints that could be the way. So if you're seeing that too, it's probably definitely we're on the right track there as well, I think.
Yeah. Okay. Hopefully that helps, that one. Is there any more questions, Param, or should we just? Okay. Oh, there's always going to be the cost question. Well, I think I've generalized in terms of where carbon black costing is. I can't be specific on N660 today, because unfortunately the market prices seem to be changing almost weekly these days anyway. So whatever price you had last week may well change for next week at the moment based on current raw material costs coming through any supply chain. But I'd say it's safe to say that most graphene products, we characterize them being monolayer, multi-layer graphene oxides, low oxygen level graphenes. Then oxides, they tend to have different cost structures based on the manufacturing methodology. So it's hard to be absolutely specific. You know, it can be multiples of 10, multiples of 100, multiples of 1,000, depending on the product, and that's in any currency, whether it's GBP, US dollar, AUD, that we offer different product platforms. So it's a very political answer, but I'd say at the moment, keep your eye on what the Graphene Council say, because the Graphene Council itself tends to also freely advertise through a lot of free issue information, what's happening as far as the utilization from a both volume perspective of graphene being produced on an annualized basis, and then a projection based on costs, which again are variable depending on who you're talking to and which methodology they use to manufacture from either top down or bottom up. So hopefully that gives you a bit more general information. Mattress, okay, that's a new one for me. I mean, is that something you guys come across?
No,
we talk about rubber-based mattress to improve performance and reduce cost. I don't like the reduce cost bit because that's never the case. I mean, I'm assuming they're talking about a blown system if they're talking about mattresses.
Yeah,
possibly.
Which I have come across blown requirements. I mean, just to give you a direct example, people using, as I mentioned, in foam applications. A foam can be a plastic, a rubber, different types of materials. And typically a blown system, the only real difference is obviously the blowing agent that they're using compared to traditional compounding processes. And the fact it's a secondary process. The real negative we see in those extra process steps, depending on the cell structure and the size of those cells and the uniformity, and that will also have a distinctive effect on what your benefit you're looking for from the graphene. Because of course, depending on how well it's been dispersed and obviously lack of agglomeration means that any cell structure is also going to likely to interfere with some of that characterization you're looking to generate in the first place. So it really depends on what you're looking for in the end, but I certainly don't see a cost reduction. Hey, Bram.
Hi there. I thought touching Brendan a little bit, you know, he's also working with a graphene company in the US. You know, how situation, can you introduce about your experience, your company, Brendan, that you're working with, and also the experience of graphene use in the US?
Okay, well, yeah, okay, two questions. Well, first of all, the company I'm associated with is this company called Akron Polymer Solutions. This evolved from work done at the University of Tennessee, which had been done in collaboration with Oak Ridge National Lab, and the primary focus there had been to get the cost down. It is expensive. In the US, we use the term sticker shock. When you go in to talk to someone about price, they say, what? And, that terminates the conversation. So yeah, it's expensive. But I think that one very important thing, and Peter, you alluded to this several times, is that yes, it's expensive, but it's used at very, very low levels. So the cost per compound starts to become more palatable rather than the raw material cost. So, and that's why you have to look at it, the cost of the compound and the performance gains as a result. But yeah, so anyway, this came out of Oak Ridge, University of Tennessee, and then the plant was built in South Carolina. So that's moving along quite well. So that's I was brought on board the company last January, so I'm still relatively new in the business per se. So it's going quite well. And sorry, what was the other point?
I'm asking about how is in U.S. market graphene use in the rubber industry. Yeah.
there's certainly a lot of interest in graphene. I do have to say that this is new. In fact, the whole field of nanocomposites has always been very intriguing. I think how people see graphene is that if we go back to the 2000s, the 1990s, there was an enormous amount of work done on clay rubber nanocomposites, and that didn't really succeed per se for a lot of reasons. One of them was the trade-off in other properties and the cost to develop compounds that would be could get around the shortcomings of clay rubber nanocomposites. What I've always liked about the graphene nanocomposites is, unlike clay, these graphene disperses very easily, exfoliates very easily in rubber, unlike clay does not without a surfactant. So in this case, we get very high levels of full exfoliation and all the property benefits that come with it. So the interest is there. I think cost is the biggest one at the moment that folks are concerned about. That's in the tire and rubber industry. Now, in electronics, that's a different field. There, it's less cost sensitive, and also in oil and gas industry. Peter, you'd mentioned that as well. It's a less cost sensitive industry. If in oil and gas, if it works, they go with it.
Yeah.
So it's you don't have that sensitivity. It's more performance driven, and in fact, it's totally performance driven, unlike other industry sectors. So it's that's where most activity seems to have been most successful.
Alan, you've been working with the graphene. I think probably first graphene. So how was the experience? You include compounders. Are you getting any inquiries? Graphene based compounds. Or
we get lots of inquiries and, like you say, lots of interest. But like you say, we haven't found that big market yet that sort of took off. And it's like you say, we've got a lot of data on different properties and things that it can improve. Getting to the similar sort of area that you're saying, that it's the lower load-ins and using it more as a performance additive rather than, like you say, an alternative to carbon black or anything. There's still interest because, like you say, it's not coming from oil and things like that. So there's some environmental interest still from using it in that way as well. So, but yeah, so nothing major taking off, but a lot of interest, and lots of projects have got a lot of interest in data. So we're almost now, like you say, we got past the gold rush phase, and now it's what's next now, isn't it? What's going to be the winning type thing? That's where we're at. One interesting one you've mentioned a couple of times is energy storage and sort of that type of thing in it. Is there any polymers in that they're looking into there in that area that could be of use, Peter?
Yeah, I mean, based on the different types of polymers, I mean, we've seen mainly synthetics, SBRs, MBRs, some aspects of other technologies such as your polyurea technology have been used and utilized, because it's all down to where and how you're looking to store the energy. So whether it's purely energy itself, so obviously batteries and battery enhancements, I mean, it's well versed on what graphene's doing in that world compared to every other graphitic product that's available in energy storage and supercapacitors, for example. So talking about fast charge energy transfers, but then also you talk about protecting materials and vapor, let's call it barrier properties, and even down to transportation such as hydrogen. So people acknowledge the fact that most things do not safely store things that are high energy. So hydrogen, obviously being this relatively smallest molecule that's available, that's the most difficult to store. So I think that's also an area they're looking to improve upon. And the way that graphene was first marketed as the smallest filter in the world. So Brendan mentions already that because of its very high aspect ratio, you've got something that's effectively very thin, very wide, but in dimensional terms is in terms of what it can elect through it in permutation, whether it's gas, liquid, vapor. Then that's an area that's most interesting because effectively it's creating a path of resistance for all of those materials to be able to get through that wasn't there before. So, but a lot of it's down to, for me, it's also down to making sure that's done in a correct manner and the correct expectation. And Alan, I'll be honest with you, a lot of it comes down to cost.
Yeah.
Because we would say you need to put a reasonable amount in to get the best barrier performance properties. And I like Brendan's comment, the fact that you're talking about a chemical additive used in isolation probably would be even better, because other products that can be used in compounding may actually interfere with those barrier properties itself. So I think there's definitely potential for usage. I think it's much more about, you know, we're willing someone to do all the work to prove it, and then obviously carrying it to end markets and actually finding a utilization and usage which will proportionately take on the cost of doing it.
Yeah.
Yeah, and to be honest, it's a bit like we're all facing at the moment. You look at the, you know, environmental sustainability movements. We all want an electric car, don't we? but reality of them being at least, you know, 25-30%, from some cases, is a lot more expensive than traditional models. We're not going to go to EV straight away. I think the market is about 6%, 7%. So we're not all driving Teslas, or there are plenty available models, of course, these days. And we're all obviously not creating environments in our own homes. We're trying to become more green and more environmentally conscious. Yeah. But there's plenty of tools out there that can do that. It's just, unfortunately, most of them carry an extra cost, and that's really where the balance is, really, as far as I can see.
EP, how is your experience in India? So, you know, you've been associated with a number of rubber compounding companies, and also, so what is going on graphene use in India?
So there are a few initiatives in India to manufacture the graphene by the chemical methods. See, it's a graphite to conversion. So in India, there are chemical methods, taking some fatty acids, they were converted, they have made attempts to make graphenes. There are some Indian companies. There are a lot of R&D efforts being done with the collaboration with the institutes, and there have been a lot of sampling to a lot of Indian tire industry and non-tire industries of these graphenes. I'm not sure about the quality or the classifications on par in vis-a-vis what is Mr. Peter or the first graphene companies manufacturing. But we made some experiments. Every company has made some experiment. As Mr. Alain was telling, there was always one batch will be very good tensile, very good abrasion resistance. The next batch, when we go, we see some sort of erratic results. Probably the methodology or the dispersion level was not okay, and we don't know really how to dispose it properly to get a consistent result. So we could not get into a concrete commercial front in many of the issues. We are still working on that, actually. We can't say we have left it. We are still working. That way, it's an R&D phase, and people are very much interested to try it out and take the advantage. Wherever our conventional compounding technology fails, we would like to extend this graphene as a step up in resolving certain extraordinary requirements of the properties. That's what I will see, as Dr. Brand was mentioning. So we should look at it as an additive, a special additive, to have an extraordinary properties. That's what I see, especially the sealing, gaskets, and even some dynamic products. This is what happened here.
Okay. Peter, if somebody wants to buy your graphene, how is the business network, or what is the business model? I know that you guys in Australia, and okay, they found in Manchester. Okay, so can you talk about the, if somebody wants to buy or represent your company, so what kind of business models are there now?
Yeah, in terms of obviously buying direct from Australia, you feel free to obviously speak directly to our manufacturing base in Australia. Outside of Australia, we have either supply agreements or distribution networks set up with partners. So in the States, for example, we're actually working with a company called Neograph. So Neograph are graphitic based, so they have graphitic products already adapted to market. So they're actually working with a partnership and collaboration with First Graphene. We've also got the same in South Africa with a company called Nanoproof. We've got nanotechnology available that they're looking to support materials alongside First Graphene. In Europe, we have more or less a direct model, so we tend to focus on having direct relationships with customers because we have quite a high content of technical and commercial staff in Europe and the UK, although we are working with a couple of partners who are also looking to get these products to market on our behalf. So working with a company called Pro Technology in the UK, We are looking to always enhance our network, to be honest. So if you keep an eye on our website, you'll see the next sort of collaborative agreements that are likely to come out, because one thing we're definitely finding in the graphene world is that I don't think there's a single model fits. I think it's very much, it's not your traditional chemical supply chain network at the moment. I think in the terms of what we've described as it being relatively new to market, and the fact it's a nanotechnology and people are looking to use very small quantities, I think in their own formulations, I think there's a natural inclination that it's much more about collaborative, cooperative agreements in a distribution basis, and working collaboratively with other companies who are interested in this technology base. It is the way forward from that perspective.
Super. Brendan, your company, how if somebody want to source graphene from your company, the Account Polymer, or the company you're associated with, how it works?
There is we've got a website, Akron Polymer Solutions website, and that would be the first line of contact. And the pretty much queries that come in, it's the same day response. So that's handled out of the office in California. So and then if people needed samples, they would take it from there. So
the market is they open for the global market, not just in the US.
Yeah.
Is it right?
Yeah, very much so. Yeah, yes, it's global. Although it's the ones I've been involved with have all been European sourced customers, where the main interest was. So certainly we're very much focused on the North American market and West European market. That's a primary focus.
Okay, that's an interesting discussion with all kinds of issues. It looks like a great opportunities there, but also a long way to go. Is it right, Peter?
I'd say we're in the midterm at the moment, Param. I think we're almost we're not quite second innings, but we're certainly well past the first innings, I think, with graphene. I think everyone's tried it, everyone's had a go, and I think we're interested in the deliverables now, and we're interested in pushing this technology forward. And I think, as we've all discussed openly, I think that's what I like about graphene is once you start talking to people about it, it becomes a very open, honest, and a forum of conversation. And I think we're all looking to achieve the same things in the end. It's just about how we actually get them collaborative to the right point. And in the end, it will always be the cost dynamic, which will be the thing that will create or retract from that discussion. But I was very keen to hear what Brendan mentioned about the fact that the more we can encourage people to look at graphene in its own right and not compare and contrast with other technologies around, then that's really going to be the key benefit as far as this technology being fully adapted going forward from here.
Okay, guys, thank you, Peter. Before I end the session today on this graphene and the rubber industry, I do like to ask you to give your final remarks. May I go with first EP? So what's your final remarks?
The graphene is the product of innovation, and it gives a potential for a compounding man. There is always a scope for further improvements. So in terms of abrasion, in terms of conductivity, in terms of any performance we look for. So it is a performance extender kind of a thing. So it's only the cost is today's constraint because of the volume. Any product during the development phase will be very expensive. So what happens when the consumption increases, more manufacturer comes, automatically the price will come down. And I think with respect to coming challenges for the product performance, obviously the graphene will pick up. Some 10 years before, people know only the Kevlar, the best fiber. Now today, many people have started using carbon as a fiber, as a standard fiber, the best fiber. So some 10, 15 years before, the carbon was very, very expensive. Now today, it's very affordable, carbon fiber. Same way, the graphene also, in a couple of years, became affordable, and we'll make use of this advantage of the technology, the nanotechnology, I think.
Thank you, EP. EP also offers the consulting services in compound development. Anybody interested, you can reach out to EP as well. He's well respected, well experienced rubber compounder and processing guy based in India. Ellen, can you introduce your company more? Include compounders and also give a final remarks, please.
Yeah. So like you say, I work for Kluwer Compounders. So we were started in 1979, a family business. So we specialized in sort of development and formulation development and things like that. So we mix ranges from 250 grams sort of perfluorinated FKMs right up to about 100 ton, sort of the whole range of thermoset elastomers from natural rubber to perfluorinated FKMs and that, silicones, all that type of thing. And for us, graphene, it's offering performances in so many different areas and properties. It's becoming sort of an essential compounding ingredient, and it's like you say, we're just trying to find the optimum things. But it's a very useful ingredient for us because there's so many different properties that it can enhance, and that's where we're looking at it from.
Thanks, Alan. Alan, is your companies offer the business globally, I guess, is right? You know, in terms of custom mixing.
We supply all over the world. So China, Australia, Europe, USA. So we supply everywhere. Yeah, and fast turnarounds are our speciality. So like you say, we make everything to order, and it's quick turnaround. So we have a team of sort of 6 technologists and 5 trainee technologists. So we're there ready to sort of get people's inquiries and turn them around quickly into a solution.
Super. So if anybody interested to produce a custom mixing, Alan is the person to contact. The Clued Compound is a place to go for it. Yeah.
Thank you.
Okay, Brendan, how is your experience and final remarks? And also, can you talk about your services as well?
Okay, well, yeah, when I finished with ExxonMobil, I had a consulting company. All the effort has been primarily on project management, troubleshooting, and we do some work on training as well. Everything on training, both tire engineering, industrial products engineering, and compounding. A lot of folks do that. So, but project management and troubleshooting is the big area that we've had most focus. With regard to the graphene, Peter, excellent presentation again, very informative, and I think it's been a very positive contribution. So all the issues that you've touched on are all very pertinent, like certainly the cost trend. I've seen some data. The cost trend remains favorable for both medium and long term. We just need to make sure it stays in that trajectory as we go forward. And then, of course, one thing we didn't really touch too much on was the health, safety, and environmental issues around graphene being a fine powder. Certainly, entire manufacturing, fine powders are a no-no, so it'll have to come in some sort of master batch, like that you had mentioned, in some form of dust suppressant as a master batch or on a carrier or whatever. That'll have to happen. But again, excellent presentation, and thanks for pulling it together.
No, more than welcome, Brendan.
Yeah, thanks, Brendan. Thanks a lot. Peter, final remarks, man.
Yeah, well, really appreciate your guys' time. It's really been a very interesting conversation from all standpoints. I'm glad that we have a single voice, which is always refreshing in any industry platform, because sometimes differing opinions are the things that stop things actually progressing. So I think progressive steps are being made. And I think at the end of the day, when you look at First Graphene as a model, we're looking to support this industry to get it to the point of being scalable, being the next generation carbon, as we've described it, and very much looking forward to enhancing the performance benefit and creating a lot of stimulated interest. And I think what's interesting as a closing statement for me is that if you look at the early adopters who are already in this industry, people are actually putting a lot of, let's call it skin in the game, as we use as a phrase, or people are looking to pay a higher transfer like they are in a football season coming over as we are at the moment. Then I'd say now is the time, because in the end, when you get to that mid-season and then full season, it's something you'll find yourself out of the game on a lot of the characterizations of when you look at graphene. So I think those people who are putting the long yards in, I know it's frustrating, Alan, particularly when you've done all the work, and guys are doing a lot of work in the background on this technology platform. But we definitely feel like we're in that phase now, where we're in the sort of mid phase of industrialization really taking off. And we really appreciate the support. And thanks for the support, Param. It's a very interesting platform to discuss upon.
Okay, thank you, guys. Thank you, gentlemen. It's really interesting, and I'm glad that we hosted this graphene and the rubber industry. And thank you all for being part of this. Everybody gave a good contribution and make the people understand about the graphene use. I'm sure it will be a great material soon. People use a lot Okay, that's what is all object about, to make them understand about the real benefits and how to utilize the graphene material. Thank you all. Thank you very much for being part
Thank
of
you.
this. Yeah, thank you.
you,
Appreciate the time. Yeah,
Thanks,
you.
Bram. Thanks.
Thanks, Bram. Thanks, Peter.
Bye. Thanks. Bye. Thanks, Alan. Thanks, Brendan. Thanks, EP.
Thank you.
Bye.
Thanks, Brendan. Thanks, Alan.
Thank you.
Okay, EP, Peter. Thanks a lot. I appreciate the time.
Yeah.
Thank you very much.
Bye now.
Guys, that's the end of the session on the graphene and the rubber industry. I'm hoping that you find this session useful to you and you get an understanding, total understanding about the benefits of the graphene and also how to use it well. Okay, I appreciate the time by the Peter Osborne, from a commercial manager of the First Graphene. Dr. Brendan Rogers is consultant based in USA. Alan Whitley is a technical manager at the Crude Compounders based in UK. And Mr. E. Paulinathan is a rubber industry consultant based in India. Thank you all for being part of this rubber industry tech talk, focusing on the graphene and the rubber industry. If you'd like to watch this session again, you always go to the YouTube at the Technology channel, check it out. And not only this episode, you can also watch all the past episodes of various discussions we had. Thank you all. I see you in the next episode. Bye-bye for now.